Is the review for the pre-assessment on adding and subtracting rational fractions with like denominators in the example of number 1, and also unlike denominators. So since we have like denominators here, we can combine everything in the numerator over one denominator. Now we want to combine like terms. So we are going to see we have m plus m, and then we have 6n minus 4n. Remember, we're adding and subtracting. So m plus m is 2m, 6n minus 4n, 4n equals 2n, and we always put it in alphabetical order. Standard form, m comes before n. And now we want to see if we can factor that numerator. We can factor the numerator. We can take a 2 out, and we get m minus n over 8n. Now we can cancel, because the 2 is multiplying and the 8 is multiplying. We can cancel that. 2 goes into 2 once, 2 goes into 8 4 times, and that leaves me with m minus n over 4n. Nice. Here we again have like denominators. However, this negative out here has to be distributed because we're going to push it up the top. We wouldn't push it down to the bottom because then it would make unlike terms. That would be positive 10x. This would be negative 10x, and they would not have like denominators. So we have to push it up to the top, and it has to be distributed to both of the terms in its numerator. So when we rewrite it, you get that. Let's distribute that negative to the x and to the 2y. That gives us x minus 2y minus x minus 2y over 10x. Now the x's are like terms. We again have like terms up here. We have an x and a negative x. We have a negative 2y and a negative 2y. So x minus x is 0. Negative 2y minus 2y is negative 4y over 10x. We can again reduce this. 2 goes into negative 4 negative 2 times. 2 goes into 10 5 times. So we're left with negative 2y over 5x. Number 3, still like terms. We have an addition sign, so we can just put everything over 30x squared. We again want to combine like terms. We have an x and an x. We have a negative 5y and a negative 5y. That will give me 2x. X plus x is 2x. Negative 5y minus 5y is negative 10y, all over 30x squared. We can't cancel anything because everything's adding and subtracting, but we can look and we see that there's a common factor amongst the numerators. So we can factor out a 2, and we get x minus 5y over 30x squared. We can cancel the 2. We can cancel the 30. 2 goes into 2 once. 2 goes into 30 15 times. We get x minus 5y over 15x squared. Still like terms? I didn't even see that. This will be interesting to see what happens here. That denominator looks very peculiar. You should sort of start recognizing those things. We'll see if what happens here. Over v squared minus 4. I don't know if the answer key is going to have what it has. That's an interesting question. So we have like terms. Sorry, my brain is going because I'm already stepping through and seeing what's happening here. All right, we have v plus v, which is 2v. We have negative 5 plus 1, which is negative 4, over v squared minus 4. We can factor out the 2. We get v minus 2 over v squared minus 4. Now, we can also factor that denominator. That denominator is the difference of squares. So it now is 2 times the quantity v minus 2, and then in the denominator it becomes v minus 2, v plus 2. Ooh, baby. Now we can cancel the v minus 2's, and that leaves us with 2 over v plus 2. Love it. How cool is that answer? Oh, did I skip 5? Oh, I would have skipped it. All right. Still like denominators. However, we have that negative that's going to have to go up there. So let's rewrite it first. K plus 4 minus the quantity 4k minus 2 all over k squared minus k minus 2. Again, I wonder if we can factor that denominator. But let's simplify the numerator. So we're going to distribute out that negative to both terms. And we get k plus 4 minus 4k plus 2 over k squared minus k minus 2. We're going to combine like terms. We are simplifying first. We're going to combine the constants. And let's see what that leaves us with. That is negative 3k plus 6 over k squared minus k minus 2. So the numerator we can factor out a negative 3, which gives us k minus 2. And now the denominator. So let's do a times c. That's not a binomial square, so we have a times c. Factors are 1 and 2. Signs are different. Bigger is negative. That does equal my middle. So that k squared minus k minus 2 becomes k squared plus k minus 2k minus 2. Remember, these two end up being those two. All right. Now we're going to factor by grouping. We're going to group these two. So we'll factor out a k, you get k plus 1. Factor out a negative 2, you get k plus 1. They both have k plus 1, and it leaves you with k plus 1, k minus 2. K plus 1, k minus 2. Oh yeah! Isn't it so satisfying when they cancel like that? That's a nice one. You end up with negative 3 over k plus 1. These are doing much better than the homework problems in simplifying. All right, we again have this that we have to distribute it out to. A plus 4 minus the quantity a minus 2 over 3a plus 3. Distribute the negative. We get a plus 4 minus a plus 2 over 3a plus 3. Let's combine like terms. A and negative a cancel. 4 plus 2 is 6 over 3a plus 3. We can factor that denominator. We can factor out a 3. And we can cancel that. 3 goes into 3 once. 3 goes into 6 twice. And we're left with 2 over a plus 1. Number 7. Number 7's our first unlike denominators. So prime factorization of 2 is 2. Prime factorization of 2a is 2 times a. What do they have in common? A 2. What do they have left over? An a. So my LCM is going to equal 2 times a, or 2a. So I need two denominators with the common denominator of 2a. Now step 2 is equivalent. So I need to convert 4a over 2 equals how many 2a's? So what am I multiplying 2 to get 2a? I have to multiply by a. So I have to multiply the numerator by a. 4a times a is 4a squared. Notice the difference there. 4a squared when we multiply. Now, nice thing about the right fraction is it's already in A's, so I don't have to do anything. We have the same denominator, so I do 4a squared over 5a all over 2a. Let's factor the numerator. There's a common factor in the numerator of an a. We get 4a plus 5 over 2a. Now, this a and this a are multiplying each other, or multiplying, so I can cancel the common factor. And that leaves me with 4a plus 5 over 2. I can't factor the numerator anymore, so that's my answer. Ooh, look at that. All right, step 1, LCM. So 6y, the prime factorization is 2 times 3 times y. 2x, prime factorization is 2 times x. What do they have in common? A 2. What do they have left over? All that stuff. So my LCM is going to be 2 times 3 times x times y, or 6xy. That is going to be my denominator. Now I have to find equivalencies. So 2 over 6y equals what over 6xy? What am I missing from 6y to be 6xy? I need an x. So I get 2x. Now my other fraction is 2 over 2x to give me 6xy. What do I have to multiply 2x to get 6xy? I have to multiply a 3y. 2 times 3y is 6y, so the equivalency would be 6y. Now we have like denominators, so we can combine them in the same numerator. Can I factor anything out? Yeah, they both have a 2 as a factor, so I can factor out the 2, and that gives me x minus 3y over 6xy. Now I can cancel this 2 with this 6. 2 goes into 2 once, 2 goes into 6 3 times. So that leaves me with x minus 3y over 3xy. All right, 4y, 2 times y, 5, nothing in common, so they're all leftovers. So my LCM is going to be 2 times 5 times y, or 20y. I'm going back. I wanted to make sure I remember the negative. Yeah, good. Okay. I just thought of the negative. Just wanted to make sure. Doesn't hurt to always go back and check. 2x over 4y equals what over 20y? Well, we multiply that by 5. We get 10x. And 6y over 5. 6y over 5 equals 20y. We're going to multiply it by 4y. 6 times 4 is 24. Y times y is y squared. So that makes 24y squared. All right, same denominators. Let's put them together in the numerator. We can, what isn't that marker? That's kind of annoying me. There you go, because it was right in the way of my extending page. Let's look at the numerator. What can we take out? We can take out a 2. That's it. All right, factor out a 2. We get 5x plus 12y squared all over 20y. We can cancel the 2 with the 20, becomes 10. 2 becomes 1. And that leaves us with 5x plus 12y squared all over 10y. Blah. X comes before before y squared in standard form. Ooh, all right, here we go. All right, we just jumped into a real interesting. So what I would do with this denominator is I would factor out a 2. Because remember, we can't do prime factorization of things being added and subtracted. We can't separate them, but we can do it for things being multiplied. So my LCM is 2n. Well, that's 2 times n. And then we have 2 times 3n minus 1, which is the prime factorization of 2 times 3n minus 1. What do they have in common? A 2. What do they have left over? An n and a 3n minus 1. Woo. LCM is going to have what they have common and then what they have left over. Wowzers. All right. We all like a good challenge. So 2n times the quantity 3n minus 1 minus 2n times the quantity 3n minus 1. Step 2, equivalencies. So what is the equivalency? 3n over 2n equals 2n 3n minus 1. So what is this missing? This is missing a 3n minus 1. So we get 3n times the quantity 3n minus 1. The other fraction is n minus 4 over 2 times the quantity 3n minus 1. So what's this missing? This is missing an n. So we're going to multiply that by n. So we get n times the quantity n minus 4. N times the quantity n minus 4. Now, as always, now that we have like denominators, let's put everything up in the numerator over one denominator. Now we have to simplify. We have two things we have to simplify here because this is a product and this is a product. So we have to do that multiplication. We're going to have to distribute the 3n into there, and we're going to have to distribute the negative n into there. So 3n times 3n is 9n squared. 3n times negative 1 is negative 3n. Negative n times n is negative n squared. Negative n times 4, negative 4, is positive 4n. All over 2n times the quantity 3n minus 1. Let's combine like terms. 9n squared minus n squared is 8n squared. Negative 3n plus 4n is positive n. All over 2n. We can factor that numerator. We can take an n out. We get 8n plus 1. All over 2n times the quantity 3n minus 1. The n's will cancel. That is multiplying. That's multiplying everything. So my final answer is going to be 8n plus 1 over 2 times the quantity 3n minus 1. Hope that's right. Number 11. All right. So the prime factorization of n plus 1 is n plus 1. The prime factorization of n plus 3 is n plus 3. They don't have anything in common. So my LCM, those are both considered leftovers. N plus 1, n minus 3, n plus 3. So we have n plus 1, n plus 3 minus n plus 1, n plus 3. Equivalencies, 4 over n plus 1 equals n plus 1, n plus, that's not a plus, that's my hands are breaking down. So we got to multiply that by n plus 3. So that new numerator is 4 times the quantity n plus 3. What is the other one? Is 3 over n plus 3 equals. So So what are we missing? We are missing an n plus 1. N plus 1. So we get 3 times the quantity n plus 1. Let's put them all over the same fraction. 4 times the quantity n plus 3 minus 3. Notice that negative. Don't forget that negative with that. Times n plus 1 all over n plus 1, n plus 3. Now the reason why we don't FOIL this is because it's factored. We want things to be factored. Yeah, but Mr. Mac, you have things being factored here. Yeah, but that's not simplified. So we have to actually distribute it out, combine like terms, and then look to see if we can factor again. So first thing is first is we have to simplify in order to be able to combine like terms. And that leaves us with n plus 9. Well, that's not real good. Look at that. Is that really what it ended up being? Boo. That's too bad. That's too bad. I wanted something that would be nice and factored. All right, that's it. Nothing cancels. Boo, that's too bad. All right, number 12. Let's factor that denominator. Now we have our LCM, 2 times 4 plus 4. Prime factorization is 2 times v plus 4. And then 3, and the prime factorization of 3. Everything is leftovers, nothing in common, so you get 2 times 3 times v plus 4, or 6 times the quantity v plus 4 is your common denominator. Another subtraction. All right, equivalencies. So 5v over 2 times v plus 4 equals what over 6 times v plus 4. So we're going to multiply that by 3 to get that 6. So multiply by 3 and we get 15v. Let's do the other fraction. I think it's like 4/3. 4/3 equals what over 6v plus 4. So 3, how do we get 3 to 6 is 2, and then we have the v plus 4. So it's times 2 times the quantity v plus 4, which equals 8 times v plus 4. You have to multiply these two, 4 times 2. You're not going to double distribute the 4 and then the 2. You just do 8. So this becomes 8 times the quantity v plus 4. We have like denominators, so we are going to put it all over the same denominator. Let's simplify. 5v minus 8v minus 32 over 6 times the quantity v plus 4. 15v minus 8 is 7v, 7, 14, 15, minus 32. What? That is a stinker of the problem. 7 doesn't go into 32. I was hoping to simplify that. Is that really the right answer? What was it? 7v minus 32. Yeah, bummer. That was number 12. All right, we'll see. Now we are combining fractions with whole numbers. So we have to turn the whole number into a fraction. Hopefully you remember that when you have a denominator of 1, it's just the other one. That's going to stay the same. So 4 over 1 equals what over 30x? We're multiplying by 30x. That gives us 120x. Whew. We have the same denominator. So I'm going to put the variable first. I'm going to write it in standard form. I'm going to factor out a 2, and we get 60x plus 1 over 30x. I'm going to cancel, because I can cancel the 2 and the 30. Makes 15. So we're left with 6dx plus 1 over 15x. The 15 and 60 can't cancel, and the x's cannot cancel because that numerator is being added and subtracted. We have 5x over 25x squared plus 2 over 1. Common denominator is going to be 25x squared. That's just going to be 5x because they're the same fraction. 2 over 1 equals 25x squared. We got to multiply by 25x squared. 2 times 25x squared gives us 50x squared. Same denominator. And again, I'm going to write it in standard form. X squares are always going to come before x's. We can factor out a 5x this time. Oh yeah. That gives us 10x plus 1 over 25x squared. We can cancel the coefficients, 5 and 25. We can cancel that variable with one of those x's. So that leaves us with 10x plus 1 over 5x. That was a good one. And I think last but not least, yes, last but not least, 6a over 18a squared plus 2 over 1. My common denominator is going to be 18a squared. That's going to stay 6a. 2 over 1 equals 18a squared. We're going to multiply by 18a squared, which gives us 36a squared. We again, since we have like denominators, I'm going to write the numerators, but I'm going to write it in standard form. So we're going to factor out a 6a, and that gives us 6a plus 1 over 18a squared. The 6 and the 18, 6 goes into 6 once, 6 goes into 18 3 times. A cancels with one of those a's. So my final answer is 6a plus 1 over 3a. And hopefully all of those answers are correct. 6a plus 1 over 3a, 10x plus 1 over 5x. There's the answers. You can check it. Let me know if I made a mistake. All right, that's pretty straightforward. You did the same steps. Each problem pretty much repeats itself. Good luck.